Hello everyone, Aaron here and welcome back to LeetCode. Today we're doing the determine if two strings are close problem. Two strings are considered close if you can attain one from the other using the following operations. Operation 1. Swap any two existing characters. For example, if we swap the B and the E here, they change places. Surprisingly enough. Operation 2. Transform every occurrence of one existing character into another existing character and do the same with the other character. So all the A's become B's and the B's become A's. That makes sense. The C gets left alone. You can use the operations on either string as many times as necessary. Given two strings word 1 and word 2, return true if word 1 and word 2 are close using this definition, and false otherwise. So A, B, C, B, C, A, we can swap the letters around to turn the A, B, C into the B, C, A. We can't make letters out of nothing. None of these letters change the length. Is that correct? Yes. Neither of these operations let us change the length of the string. So this we can immediately see as wrong. C, A, B, 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 A, B, B, C, 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 C. It gives us this description here. We swap the A and the B. That makes sense. We turn the C's into B's and the B's into C's. That makes sense. Then we turn the A's into B's and the B's into A's. That makes sense. Okay. They can be quite long. At least they're only going to be lowercase English. Right. Okay, so there was a bit of a silence there because my gut instinct, and this reflects on the kind of work I do, my gut instinct was graph search. This is a graph search problem because I have a state and I have a goal and I have actions that I can apply to the state to move to a new state. That screams graph search to me. But I think my instinct is wrong. And the reason... Well, there's two things telling me that my instinct is wrong. The first is that these lengths are large. The lengths are large and the state space is huge as a result. The second thing telling me that I'm wrong is this particular operation is very powerful. If you can swap any two characters, we can be quite selective in the ones we swap in a certain manner, such that we do a sort. For example, this applying operation 1 an arbitrary number of times lets us sort the string. So here, for example, if we take this BCA and ABC, this ABC and this BCA, and we sort both of them, they're the same. They're both ABC. So we know there must be some sequence of operations. In fact, there must be some n log n sequence of operations, because we could just do a merge sort, that would let us convert these words between each other. We couldn't do that here because, again, the length changes. And here, well, no, here's more difficult. If you sort both of these, you get A, B, B, AA, B, 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 C, which is different. So, motorbikes are loud outside of my window again. I'm moving in a little over a month, so hopefully there'll be much less road noise. Swap any two existing characters. This is the same as saying we can do a sort. So the approach I'm taking here is not graph search, it's called normalization, or normal form. I want to convert these strings into some normalized representation where if they are close, they have the same normalized representation. So I can immediately say, yes, that's true. And I want to turn that into false if the normalization, if the normalized representation is different, then they're not close. So that's what I'm trying to do. So the first thing I can do is sort them, but that doesn't help us with this case. because, well, as we can see here, this operation is, what's the way to put this? It's cardinality preserving. So if I have 3 A's and 2 B's, afterwards I have 3 B's and 2 A's. So although the letters haven't changed, I've still got the same set of letters. And I still have the same set of cardinalities. It's just they no longer pair up. Oh, that's it. Right. I know how to solve this problem. Okay, so what we need to do, because the cardinality is preserved, but they can be moved between any 2 letters, all I care about is the set of letters involved. That needs to be the same between the 2 strings, because I can't produce new letters. I can't introduce a Z into this string in any way, because it's always involving an existing character. And the collection of cardinalities, so the letters have to be the same, and the collection of cardinalities has to be the same. So here the cardinalities of the string are 1, 1, 1, 2, and 1, 3. As long as the output string has 1 cardinality 1, 1 cardinality 2, and 1 cardinality 3, then we can manipulate these letters in such a way that we can end up with those cardinalities as well. So the normal form, actually let's call it NF1, NF1 is self.normalize word1, and NF2 is self.normalize word2, return NF1 is equal to NF2. If the normalized forms are the same, we return true. If they're different, we return false. So now we need this normalized representation. So what I want to do is basically I want to count how often each letter occurs. And that will tell me 2 things. Let's use Python's library for this. Collections counter word. So what this tells me now is the keys are the set of letters, and the counts are the sequence of counts. So I need the letters involved. That's just a set. And here what I want is I can't use a set for the counts because I might have, say, 2 A's and 2 B's, and I need to make sure that I still end up with two cardinalities. So I can't just use a set because that would throw out one of the 2 cardinalities. So I use a list, but to make sure they're always in the same order, I will sort them. Is that it? That might be it. Oops. Ugh. Hang on a moment. Okay. So it works for the first example, but that one we knew was handled just with this case here. Let's use all the example test cases and see what happens. So this one here should fail because although the set of letters is identical, this part is the same. They both involve just an A. The cardinalities are different. This has a cardinality 1, this has a cardinality 2. And then the third case here, we have A, B, and C. So the keys are the same. We have a 1 cardinality 1, 1 cardinality 2, 1 cardinality 3. We have 1 cardinality 1, 1 cardinality 2, 1 cardinality 3. So the cardinalities are all the same. In fact, we can just inline all of this, can't we? We don't need two pointless variables for that. Let's submit it, I guess. I don't know. I think I got very lucky with this one, and I resisted my gut instinct in the right way. Excellent. Yeah, I think... Okay, you could, in theory, do this with a graph search. It would be way too slow. The space is huge that you need to search. So here, this normalization approach is much, much more viable, because this is order n, well, this part is order n, this part is order n, this part is order n log n, where n is the length of each word. The words must be the same length, so it's fine. We could probably do a even faster rejection on strings that are of different lengths, but that's a special case that we don't really need to handle because it's handled quite nicely here. The length is the sum of the cardinalities, so it's implicitly covered. Right, that's it from me. It's been quite a good week. Do remember to like, comment, subscribe, all of that good stuff. In particular, comment if you have any suggestions for the 100 subscribers special, because we're currently at 94. And that, whoa. I think next week I might have to worry about it. The other thing I need to mention is that next week is going to be my last week before I'm on holiday for a bit. I have a couple of videos recorded, nowhere near enough to cover my holiday period until January though. So video frequency is going to basically take a nosedive. Other than that, have a good weekend. Have a good run up to Christmas or whatever you celebrate this time of year. And I will see you next time. Bye.